Alright, so I'm redoing this problem. It's not the same video, I'm redoing it. Okay, so you can see the door frame. There is the door. Here is the lever arm. That's pulling it counterclockwise. Here's the hinge. And from that point, 47 centimeters away. Okay. So for part A and B, they want us to find the perpendicular components in order to get the torque. So for A here, here is the door frame, and here's the force, the line of action. So there is a parallel force and a perpendicular force. Okay, well, again, they want us to use perpendicular, and again, parallel with this force, perpendicular to that force. So, so here's the perpendicular force. So I went ahead and it's just what is the perpendicular force? It's the force multiplied by the sine of 15 because it's opposite the angle sine. And here, so since we got the force now, all right. Well, since we know what the perpendicular force is, we can go ahead and plug it in here. So the radius we know, and we just convert it 0.47 meters, and then that perpendicular force, which happens to be the force multiplied by sine of 15, is that the 25 Newton force and sine of 15 because it's the perpendicular force. So the torque for this one is just 3. Okay, now for B, let's see. Okay, now for B, they want us to find it, the perpendicular force of the lever arm. Alright, so here is the line of action. That's the line of action it's going to take. So that would be the parallel force. And the perpendicular force is this. Okay? So this time it's going to go, and it's going to be the radius. So here is the parallel radius. Okay, so it's just r sine of 15. Again, that angle right here is opposite, so it's sine of 15. And so here's the equation again. So now the perpendicular force for the radius, okay, it's going to go ahead, the radius 0.47 meters multiplied by sine of 15, because we're just plugging this in for RP. Okay, and then of course the force, which is just 25 newtons, and it's the same answer, 3. Now C, the torque. So for C, they want to know what the torque is. The torque is positive. The torque is positive because it's moving counterclockwise. It's being pulled counterclockwise, and anytime the torque is moving counterclockwise, being pulled counterclockwise, then it is positive. If it would have been clockwise, then it'd be negative. But in this case, it is counterclockwise, and the torque is positive.